Okay, today we are going to understand about motion. Let's begin. Let's start from distance and displacement. We all know that distance is nothing but the total path covered during a motion, and distance is a scalar quantity, whereas displacement is the shortest path made, and this is a vector quantity. Let us now go to the topic speed. How do we define speed? Speed is defined as the distance covered per unit time. In other words, this can be written as speed is equal to distance by time. Okay, so speed we know is measured as meter per second, and this is a scalar quantity. Scalar quantity. Let us now write about velocity. Then what exactly is velocity? So velocity is the displacement made per unit time. Per unit time. Notice one thing here very carefully. Here we have written something like covered. We have written here, and we write here made. Okay, there's a difference here. You can't cover displacement. You can make displacement. So just keep this in mind. And this can be then written as velocity is equal to same d by t. Only thing is here it was distance, and here your d is displacement. Okay, and unit is same, meter per second, and this is a vector quantity. Vector quantity, don't forget this. Okay, now let us try to understand something else. Let's try to understand then what is average speed. Okay, you know, average speed is nothing but total distance covered over total time taken. Okay, which means we can write this as average speed. The symbol is this. There's a bar here, you can see, for average, is equal to total distance by total time, okay, taken, covered. Then what do we mean by average velocity? Average velocity. See, average velocity is nothing but the same as its own definition, which is your displacement made per unit time, because there is nothing called total displacement. Displacement is only one single component. So in a whole journey, you can have a part of the journey or you can have full journey, but your displacement remains same if you have covered the full journey. Okay, I'll give some examples here. So average velocity is still written as your displacement by time. Okay. Now I'm going a little up. I will explain this thing. Okay, let's say you go from here, and then you go here, and then you come down here, and then you go like this. So this is one path you have taken you have chosen. Okay, and this is A and this is B. Let's say this is C and this is D and this is E. D, this much will do. Let us say this is 3 meter and this is 4 meter. Okay, so if I have to discuss from A to C, then I would write my distance is equal to 7 meter, whereas my displacement will be root of, because this is my displacement, see, this is my displacement, so it will be 3 square plus 4 square, which will give you 5 meters. Okay, so this is your total distance you have covered between A to C. Similarly, if you are talking of from, let's say, A to B, then your distance will become here. Let me mark this as 3 meter. Let me mark this as 3 meter. Let me mark this as 4 meter. And again 3 meter. So if I add all of this, so 7, 8, 9, 10, 13, 17, 20. So my distance will be equal to 20 meter. Whereas my displacement will be from A to B, which is just 4 plus this 4. So it will be 4 plus 4, which is 8 meter. See, like that. Okay. Now let us do some question here. Okay, let's do one question here. Let's say question number 1. Question 1. Okay. And the question says, a car is moving from A to B as shown. Okay. Find the speed and velocity. So let's say the car is moving in this way. Okay. So 12 meter, 13 meter, A, B. Now, if I have to solve this question, then to find speed, I need the distance, right? And then the time. Let's say it takes him 5 seconds and it takes him 4 seconds. So what is the total distance covered? Directly we can write 25 over 9. This much meter per second. Then what will be the velocity here component? The velocity will be displacement by time. Now which is the displacement here? That's a question here. So your displacement here is from A, it was a starting point, and then it goes up to B, this way. This will be nothing but root of 12 square plus 13 square, which will be nothing but 144 plus 169. If I am correct, then it's 13, 10, 11, 1, 2, 3, 313. Okay. So if I have to write the displacement, then it is root of 313 by the time taken. The time taken still remains same. See, the time is same, since to make a displacement for this journey, displacement for this journey, the total time is 9 seconds. Many students get confused. What they try to argue is that why am I taking 5 plus 4? Question is that the displacement we discussed in the second stage. See, first you spoke about the distance. Actually you went this way. So if you go this way, you have taken 9. For this part, the displacement is this. You did not go this way. You went this way only. You have gone this way actually. This way you have gone. See? So you have taken 9 seconds already. Okay, so for this condition, the time taken is 9 seconds, and on that only we are working. That is why we have taken 9 and not less than that. Okay, so whatever answer you get, that much meter per second. So I hope there is something clear, and then we'll continue now in the second part of this. Okay, so I will end here for this part of the video. Okay, and then continue next part.